I see my screen? Or actually, you probably can't see it yet, but
It's loading now.
okay, here we are. All right, are we here?
We're good.
Okay, beautiful. All right. So what we're gonna do, we're gonna walk through, yes, the last class from 2 weeks ago, with special attention being paid to the last segment, where we actually had the top level prediction, and then we were projecting it onto the projected proportions of the individual states, because it was actually fairly complicated how you went from point A to point B. And then pretty much today, we're just going to actually practice different variations of that to figure out how, if you can improve the accuracy for the low level forecasts. All right. Everyone ready?
Yep.
All right. Beautiful. All right.
Yep.
Great. Edwin, I'll take that as a yes, that you're in good shape. All right. Okay, everyone, let's go ahead. So in the Slack channel, if you want to take a look, right, hierarchical time series, top down, notebook only. Everyone there?
Yep.
Okay. All right, so what we're going to do, we're just going to walk through this, okay? And then we should just be able to run the cells one by one just to refresh ourselves of what was going on. And then from there, we'll go ahead and then add in some additional steps. So let's go ahead, right? So the idea then, what we were going to do is make forecasts not just for the country as a whole, but for each of the individual states within the unit US. Okay, which is an intrinsically more complicated problem, as we saw, right? Because if you just have a single time series, profit is pretty plug and play, so it's not too hard, you know, just to kind of like do some function calls and get a forecast and looks pretty good. But actually taking that and then kind of working it down to lower levels is a good bit more complicated. And then we are kind of getting into more rarefied air, right? Like the sorts of things that don't come as easily. There's not a neat library for it, and so it requires, right, some more intermediate to advanced levels of different types of pandas functionality. And so that's where we're going to be spending most of our time today. But before we do that, let's take like 40 minutes and just make sure we're good with what we did yesterday, or rather 2 weeks ago, okay? All right, so moving ahead. All right, let's go ahead, load in the cell. All right, and so this is the data set that we had. So previously, we had just been looking at the US totals, but this time, right, we have the individual states day by day. And then the idea then, if we do the grouping, okay, this gives us every single day within the time series, and then the value for the positive increase, which is basically how many new tests did we find that particular day, okay? And then the idea is, if we're going to be making forecasts for all of the individual lower levels, these days here where there's just straight zeros, it's not too bad if you just have a single time series, but a lot of these underlying states, their actual data is spotty to begin with. So the values for which there are no cases at all, we're just going to go ahead and remove them, which is what we're doing over here in cell 5. Okay, we're saying so wherever the date is greater than February 2nd, 29th, February 29th, just grab all those dates and then get the 3 columns that we care about: date, positive increase, and state. So we do this. And so now if we do it, right, our actual time series will always be populated with at least some positive values. And so it makes some other things easier. Okay. And then all we're doing here, so this is what this looks like right over here, the daily totals, and we're just saving this as a variable right over here. Like this. All right, and then the idea is, right, what we want to do, right, we were actually not just taking the state totals, but getting their proportion of the country total for every single day, because the idea is we're going to take a top level forecast and then project it down to the individual states. All right, so the same thing, right? This lesson, we basically do tons of merging, right, over and over and over again. So this is the first one of probably about a dozen different things we're going to do today. So, right, so we're going to take this thing totals, like this, okay, and then we're going to merge it into our original data set. And so in this case, we're just merging on date. Okay, and then notice over here, the rename. This is just making some of the columns appear a bit better, because if you have duplicate columns on merges, you get this underscore X and underscore Y. So this is just to make the results a bit more legible. So this is what this operation does, right? We're taking this, the date, the daily numbers, and then merging it in with the individual state level numbers. And so same thing, next line over here, just saving it as a variable. And so now if we run cell 10, all right, this is what we should have, right? Every single day, every single state, how much it had that day, and then the actual country total for that particular day right over there. All right, and then this value, right, line right over here, portion, right, with state total divided by country total, right? It's just this number divided by that number. And so that tells you what percent of the total happened each and every day. So if we do this, we take a look at DF head. Okay, right. So on September 18th, Alaska had 116 cases, which was about 0.2% of the country's total for that particular day. And we get that, right, moving on. And then the idea is what we're doing here, just doing a quick double check just to make our proportions are coherent. So the idea is if we group by the day and then sum up the total portions, these things all add up to 1, which is what we want. Okay, so let's do a quick check. Everything copacetic?
Yep.
Okay, yeah, this is what we did right in the beginning of class yesterday, but just some basic processing we have to do. And so what we're going to do now, all right, this is an intermediate step. We can probably skip over this, but just as a quick way, actually pivoting is a useful, not always commonly used function. The idea is what we're doing over here, we're taking our individual states and then just unpacking them into their individual columns. And then we have the date index right down over here like this. So basically what it tells us, for every single column, we have the state, and then it's day by day proportion of the total. And so the idea is if you visualize this, it is maybe just an intuitive way of thinking about how these values change over time. And then at the bottom is probably fairly stable. But as we know, at the very, very top, a number of different states have taken their turns being in the top and the bottom, things like that. It turns out that is pretty common impacts, important impacts for some of the projected proportions. So, all right, so here we have like that right over here. All right, everyone remember this function, the build hierarchical forecasts? All right, the idea is if you take in a data set right over here, okay, the column that you want to use for your different levels, and then the date index, what it'll do then, okay, it'll take this, and then once you're done with it, you'll have a result that looks like this, right? So every single date that we have inside the date index, right? And then every single individual level value right over here, and then the projected value right over here like this. Okay, and so this was useful for just some subsequent steps that we had. So we run this. All right, and just as a little bit of a refresher, right? So here, DF would be this thing right over here, like so. Okay, level var, right? This is the column that has the unique values we want to build the forecast for. In this case, it would be the state column because we want to forecast for each of the individual states. Okay, and then the date index. Does anyone remember by any chance what we used this one for? Bueller? Yeah, the idea is the individual states don't always have consistent dates. And so sometimes there are missing values in between them. So the idea is this tends to work a bit more smoothly if we just have some sort of master index, and then we just merge all the predictions into the master index so that way everything's consistent. That's the idea with this one right over here, because if we recall, if we just look at the individual states, there is df.group by state. over here like this. So if we take a look here, right, for our individual states, they don't all appear in equal values. And so therefore our predictions and then the stuff that we fit things on, it might be inconsistent. So therefore what we're doing is we're just going to specify a date range manually and just merge everything back in. It just prevents some error messages from happening. All right, so what we're going to do here, right, we're creating training and validation. And so in this case, we're just going to say the validation set is everything that happened in September. And then validation training is everything before that. So this is the query right over here, right? And we're just saying, right, where it's less than September, make this the training set. And then where it's more than September, make that the validation set. So we'll run that. Okay. And so basically, this is where the lab began. All right. This is what we spent probably about 40 minutes on last week. And so basically what we're doing, right, first thing we did is we made a top level forecast for the entire time series. And so the idea is based off of previous classes, we added the holidays manually. We used a 7-day window, okay, and then used the prior scale right over here, 0.25. I just added this in at the end because I thought it was a good idea, but if we wanted to, we could have validated for that as well. But we do this, okay, DF train cases, just to make sure we're clear what this is. Okay, these are just the daily case totals, right? So we have the individual state totals here. So we group it by date. We take the totals for the state and then we sum them together. Okay, and that's what gives us this right over here. So this is kind of the master time series we're going to be fitting our model on. If you remember from previous classes for profit, the date column has to be DS and then the state total has to be Y. All right, so we're going to rename it right over here. And so this is basically what we're going to go ahead and then fit profit on, is this value. Okay. So here we fit. And then future, right, is pretty much just the date column. In this case, we're saying add on 15 additional dates and then make the predictions. So we'll give it a minute. So now if we take a look at predictions, okay, what is probably most useful here, right? This is the actual final predicted value right over here like this, right? And we can see here the different time components. So, you know, the weekly, the annual, different things for the holidays right over here. The overall trend that we have, right, and so on and so forth, okay? But the idea is the final prediction is Y hat right over here like this, okay? So we do this, and then now what we're going to do, so this is kind of our top level prediction that we're going to go ahead and project onto the states, all right? And then here what we're going to do is go ahead and then use this build hierarchical forecast function, right? So we're creating the date range. So in this case, it's going to be February 29th to September 16th. All right, we're just going to rename everything to DS and Y because that's what profit likes. And then we're just going to take this, right, go through this function, build hierarchical forecasts, and just let it rip. Okay, so it's going to go ahead and then fit 56 different models. And then the basic idea is when we're done with this, okay, the last 15 dates should essentially be the predicted values for the ratios from profit itself. And that's pretty much what we're going to go ahead and score ourselves on. All right, so we'll give this a few minutes to run. It takes a little bit of time. All right, and this is kind of where we were at about maybe 2 to 2.5 hours in the class. And then we're getting close to the point where we kind of ran out of gas a little bit and probably needed an additional 45 minutes to talk about how to actually kind of make sense of predictions and combine things. But it was already about 4 o'clock at that point, so there was just nothing left. So we'll give this a minute, let it run. Does everyone have this on their computer going?
Yeah.
Okay, great. And then Ricardo and Edwin, I'll just assume that Shell is speaking on your behalf as well.
Yeah.
Okay. I assume just as much. All right. So we have this thing going. We'll give it a few minutes. Okay, when we're done, it should be something like this, right? Different ratios for each of the individual states. And so, la-di-da-di-da. And that was basically the lab, right? So we had the top level prediction. We had our forecasted ratios. And then we spent about the last half hour combining the two. There's a chat. Okay, no worries, Edwin. Not a big deal. Ooh, all right, so we'll just let this little thing run. It's getting there before too long. Give 1 minute here, 50, 51. So any second now it should be done. You know, for some reason, the forecasts for Vermont were particularly bad. I'm not sure why, but I haven't really looked into it. All right, so, okay, all right, so we should basically be finished here. I think we're done. I think it's finished. All right, let's take a look. Yeah, all right, so it's done, right? So now if we take a look at estimated ratios, okay, these are our projected forecasts right over here. All right, so the idea is, right, we're going to take our predictions for these individual dates and then project them right on these predicted values over here. Rashab, who's not with us today, made the note, right, that some of these things might not truly add up to 1. Like, we're not necessarily going to be constrained by that. And then also we have the issue here, right, of the negative values. You can't really be a negative percent. So there is a little bit of housekeeping we have to do. All right, so the subsequent cells that we have here, all right, so for a few of these rows, literally profit at the very beginning of the time series, there's just not enough there to make predictions. And so we get these NANDs. All right, so this cell that we do right over here is just getting rid of the cells, the rows that have entirely empty values because they don't really serve us anything, right? So essentially here, estimated ratios, iLoc, not null, all axis 1, right? So basically means all the rows that have entirely non-empty values, we'll keep those, and then we'll get rid of everything else. And then the big idea here, right? So once we're done, okay, we got rid of those values that were entirely missing. So that's the only reason we did this step right over here. And this is something Rashab brought up 2 weeks ago, right? The idea is if we have these proportions for each of the individual states, these things should add up to 1, okay? But we don't get that here. All right, so what we're going to do is we're going to go ahead and just do some scaling. And the basic idea here, what's tricky, is remember here, so estimated ratios, some of these things were actually negative. Okay, so how do you take the percent of a negative? Right, so these values right over here, if you remember Mary from previous class just would have set these to 0, which is probably not that big of a deal because the negative values actually are quite small. But if we wanted to be careful about it and do it in the best way, basic idea here, let's take the first row, is right over here. Okay, notice here the date column, we don't want to do anything with that. So we'll just grab the first one from this. All right, so this just gives us the numeric values from the very, very first row. All right, the minimum value, right, is a negative number. So the basic idea is if you want to take percents with things with negative values, what you do, you take the smallest number that you have, take its absolute value. And so what we'll do here, all right, we're going to add the absolute value of this negative number to every single value inside the row. This is just a little bit of scaling. All right, so if we do this, now if we take a look over here at row vals, okay, the smallest value is exactly 0 and not negative 0.0038. And so the idea then now, if we do this, right, and divide by the total, right, we get these proportions right over here. And then the idea is, if we add up all these values, okay, now we have a true proportion. It's 0.99998, whatever, but that is close enough. And so that pretty much coerces everything into a single, like a true proportional value, right? So everything adds up to 1. There is not really a clean way to do this in pandas or NumPy with just kind of their regular commands. So essentially what we have to do here is we have to take our data set and then loop through every single row and then perform the operation that we just completed. Okay, and so we may be seeing this for the very, very first time. Iter rows right over here. Okay, are we familiar, just to kind of make the enumerate function in Python? You know, for index, val, and enumerate, and you put in the list or the iterable, and it gives you the index position plus the actual value itself.
Kind of. I remember you mentioning it.
Mentioning it. I know actually some of you have actually used it in your own homework. So I know it's like there, right, in your head somewhere, things along those lines. All right. Iter rows is kind of the same thing, but it's just more for a data frame. So basic idea here, if you want to loop over a data frame row by row, there are a few different ways to do it. Basic idea though, we'll just grab the first 5 here just to make it a bit. All right, so if you do this right over here with the iter rows, essentially what you do here, right, this is the index, and then this right over here, these are the actual row values themselves, and then they basically exist as pandas series. All right, so for every single row, you have the index, which are the columns, and then you have the individual row values right over here like this. Okay, so that's the basic idea. It's one of the more convenient ways if you want to go ahead and then loop through a data set and then do stuff to every single row, right? So what we're doing, this function says, right, taking a data frame, grab the numeric columns, loop through every single row of those, take the row, add in the absolute value of the smallest value, and then divide by the sum. And then for the corresponding index in the original data frame, set those values to the row values right over there. Okay, so if we run this, all right, the big thing here, estimated ratios, once we're done. Okay, now everything truly adds up to 1. So that way, when we're taking our top level forecasts and then projecting them onto the individual states, the results will be coherent. And so all the individual parts will add up to the whole and vice versa. All right. Right, these PRIDs, these were our original predictions for the top of the data set, right? So these are our forecasts for the entire US, okay, right over here like this, okay? And then here, right, these are estimated ratios for each of the individual states that have been rescaled so that way we have true proportions, okay? And then this is where we were at probably around 3 o'clock. And I think this is where we probably spent 25 minutes talking about something that really probably took probably closer to an hour to go ahead and go over fully. Okay, and so that's really going to be the beginning of this lesson. And so we're going to make sure we walk through all the details of marrying the top level forecast with the individual parts. And then we're going to go ahead and then test through some different versions of it. Okay, questions so far?
Nope.
Nope. Okay, beautiful. All right. If Shella says it, then that's just going to be assumed to be the case. All right, I got a message here. Okay, Edwin's good. Ricardo, hopefully you're in good shape too.
Yeah. Good.
All right, beautiful. Okay, all right. So we have our country level forecast right over here. We have our estimated proportions for each of the individual states right over here. So now we have to marry these two. We kind of know what we want to do, right? So the idea is, right, so 28,269, that's the predicted value of COVID cases for the entire US. And we basically want to say, since, Texas is predicted to have 10% of the daily cases on this particular day, we just want to take this value, right, and just sort of say take the 10% from Texas and then just sort of take it from that value right over here. So therefore the predicted value for Texas should be 22,870 or something like that. Okay, so it turns out it's a little complicated to do this. And so you have to go through a few different operations just to kind of make everything copacetic. All right, so what we're going to do here, right, we're going to go ahead. Again, we don't always necessarily have the same dates on all these different data frames. So just to make sure everything matches, we're going to go ahead and do the merge. So the idea is, we take our predictions for the entire country, right? We take the time, we take the predicted value, and then we merge it into our estimated ratio. So if we run this, right, we have the predicted value right over here. Okay, it makes some things a little bit easier. All right, and so this line, we'll just go ahead and then save that. Okay, and now the idea is we just want to be able to operate on the columns that have the word ratio in it right over here. So we're just doing a quick loop just to get the columns that have ratio inside of it, which is what we're doing right over here, right? So call for call and estimated ratios dot columns if ratio in call. So for every single column inside this data set, right, if the label contains the word ratio, we're going to go ahead and keep it. So once we do this, all right, these are the states we want to go ahead and work with. And so what we're going to do here, all right, these are just the columns with the ratios themselves. All right, and then in a manner that is somewhat similar to what we did before when we looped through the data frame, let's take a look. So what we're doing right over here, we are just making a copy of this guy. Okay, just with the idea is we might want to keep this for something. All right, and so therefore preds df, right, is just this thing right over here. And then so same thing we're saying, so go through every single one of these rows that we see right over here. Okay, and then what we're going to do then, we're going to say the value of this row is going to be equal to itself multiplied by the value of y hat at that same position right over there. Okay, so essentially we're saying this is row 0 right over here. And so we're going to go ahead I think that's going to work. And so we're going to take, right, so the index position that's listed right over here, take the value of y hat and the estimated ratios column, and then take this value and then multiply it across the entire row right over here like this. Okay, and so we're just looping through that every single time, and then we're saying take that value and then just make that the new row inside preds df. All right, so we do this. So all we're doing, this is the actual step, right, where we go ahead and take the top level prediction and then project it onto the individual states for every single day. And so if we run through this, right, preds df when we're done will look like this. Okay, and so these are predicted values for every single one of the individual states every single day from the top of the forecast. So this is really the top-down forecast right over here. Okay. And I think this is where we actually really ran out of time. This is where Rashab asked, so how do you actually validate these values? And I said, it's a little bit complicated. And then I just kind of blew through some stuff in about 5 minutes before it was time to go. All right. So this is really where we're going to spend the bulk of our time today. But before I do that, let's do a quick check for understanding. One, what these values actually mean, but also some of the intermediate steps we took to get there. Okay. And then if we get some silence, things like that, then that'll be good enough for me. Okay. So can I go on?
Yep.
Okay. All right. So these are actual forecasts. All right. But the last thing we're going to do is actually talk about how to score how we did, right? Because Rashab had the perceptive question last time. So we have these, predictions right over here, but how accurate are they really? Okay. So, I mean, some of them look reasonable, right? I mean, if you look over here, the values for California or for Texas, right? These sort of agree, I think, with kind of some of the regularly observed values that we have. The idea, though, one of the problems that's inherent to the thing that we're doing here is that for some of the individual states which just don't occupy very large portions of the total, we'll find here their values are actually fairly erratic. Okay, so what we're going to do here is we're going to score both the top-down forecast, the original forecast itself, and then also how it performs when projected onto the individual states. Okay, so there are any number of different metrics you can use. Mean average percent error is a fairly easy one to think about. So just how off was your average prediction by as a percentage. So what we're going to do, all right, these are the daily totals for the US in our validation set, right? So these are the actual values. So let's go ahead and save this. All right, and then these here are our predicted values. So what we're going to go ahead and do here, right, we're just going to go ahead and then merge the actual values with the predicted ones right over here. Like so. All right. And then also, notice over here, some of the dates didn't quite match up. So over here, we're going to go ahead, right, save this, and then just drop these two last missing values right over here. All right. And then the idea then, all right, so this is mean average percent error. So just the actual value itself divided by the prediction minus the true value, and then dividing it by the total right over here, and then taking the absolute value. For whatever it's worth, if you go back through some of the individual values, particular Massachusetts actually did a redaction on one of these days. So in the beginning here, some of these numbers are artificially bad because it was not changed here. But a few of these days, there are actually some negative values for the state totals. Because I'm not sure, sometimes states will go ahead and then retract some of their previous numbers. And so it might show up as being negative, $4,000 or $5,000, 4 or 5,000 cases on a particular day, but it's because they overcounted previously. So that happened here a little bit. So it throws some of these results off. But in any event, if you look at this, okay, and then same thing, if we add this up, on each of the individual days, these were the day-by-day MAPEs, all right, in our validation set for the data set as a whole. And then if we take the average, okay, it's about 0.19. The true value is probably closer to about 0.16, but there were some negative values I didn't go ahead and remove. But if we wanted to, we could go ahead and do that. So this is basically the accuracy for the top-level forecast. All right, so again, we're just taking the predicted value minus the totals and then dividing by the sum like that, and that just gives us the average percent. Okay, so that's how we did at the very, very top. And then the second question is, how did we do okay, on the bottom down here, which is actually a more complicated question. And again, this is one of the problems that is intrinsic if you're doing these top-down forecasts, is that you can fit your first model relatively easily, but projecting it onto its lower portions might be a bit difficult, especially for the ones which are not very, very large portions of the total. Okay, so let's take a look. So we're going to do some fancy indexing, okay, to get this to work. So we take a look over here at our validation set for the data frame. Right, so we have the day, we have the state, the country total, and then the predicted proportion right over here. All right, so what we're going to do is do a little bit of grouping. Okay, so over here, right, you group by state and then the data set, and then just grabbing the last recorded value. And so here we have the multi-level index. So for each state right over here, we have the corresponding dates right over here, and then the state total. All right, so what we're going to do then, this is just a quick reordering. So we're going to save this. Notice here, if you take this and then reset the index, okay, it just turns it back into a normal data frame. Okay, so that's what we're doing right over here. So state values is just this with the index reset, which you can see right over here. So let's do this. All right, and then what's going to come next? Okay, we're going to take PREDS DF. Remember that the kind of a tricky, tedious thing about this is that everything has to match up on the same date for everything, which is a big reason why we frequently do different types of merging. But PREDS DF, this is the data frame with the actual predicted values for every single state, okay? There's not an actual date column, so we're just going to go ahead and then add in the date column from the original ratios data frame. And that's what we're doing right over here. Okay, so same thing. Now if we look at PRIDS DF, we have DS right over here like this. Okay. Is everyone here?
Yeah.
Okay, again, this is just going to be useful just to making sure different types of dates match up side by side. All right, so what we're going to do here, all right, we take a look at our variables. So if we look at state vals, all right, we have to do some reshaping of our data set. Okay, right, so state vals, right, we have the individual states and their daily totals right over here. Okay, our data set, PRIDS DF, is actually shaped in the opposite way. Okay, we don't have a state with a column with each of the individual states. Right, in our case, the individual states have their own column. Okay, so what we're going to do then, okay, and I remember, Ricardo, you were actually very fond of this method once you understood what it did. And then Shella, in our class, we talked about this a little bit when we talked about the hierarchical time series stuff, is the method called MELT. All right, so if we run this, okay, it can maybe be a little tricky to understand what's going on, but the basic idea is, right, instead of having a single column for every single state, we took all of these columns right over here and then basically just squashed them into one right over here. Okay, so our data set went from being very, very long, wide, to being very, very tall. All right, so for example here, we do this. Right, at 195 rows, which is just all the individual dates in our time series. And so if we do this, right, we can see here it's a lot longer because now we have 195 times 50. Or actually 195 times 56, excuse me. Okay. But the idea is if we do this, our predictions for each of the individual states on each of the individual days now corresponds same shape that we have right over here like this. So these things are formatted in the same way. And so therefore we can go ahead and then do some merges and then perform more operations on a data set. Okay. Is everyone there?
Yeah.
Okay. Good. All right. So what we're going to do over here, right, we'll go ahead and save the variable. And then I guess I could have done a merge here. I did something different. I'm not entirely sure why. So now we're just going to check, right, what dates in our predictions are corresponding to what's inside of our validation set right over here. We're basically just kind of grabbing the dates from September 2nd onward. All right, so creating the query right over here. And so big thing, right? So starting on September 2nd, which is our validation date, and then going to the very end here, September 16th, okay? Now we have the corresponding predicted value. Right, and then what we do over here, if you look at state prids, remember these are the predicted values for the individual states, okay? The column here is called AK ratio, and so what we eventually want to do is we want to merge it with this column right over here like this. So all we're going to do here, right, the idea then, if you do this, state prids, have the variable column, okay, and then just doing some strings processing, so string.split gives us this. We're going to grab the first state, right, the first item from the list. So we have this. And then something that you can't see here, okay, each of these states actually has an additional space. All right, so for example, if we do this, unique, okay, it is not just Alaska, it is Alaska with a space after it. Okay, so what we're going to do here, just to get rid of the space, ship removes white space from the beginning and the end of strings. Okay, and so now the values in this column will match what we have in the other one. So we'll go ahead and make the change, right? And so now the values in the variable column match what's in the state column over here. So same thing, like we do a lot in this math lesson, we go ahead and do a merge. Okay, and so this is actually what we want, right? So we have the date, we have the actual state total right over here, and then we have the predicted value right over here. And so then we can go ahead and calculate our error metrics. Okay, because now we have a line-by-line comparison between the two values. All right. So this line just does it officially. Most of the way this notebook is set up, a line will just show you what the data frame looks like so we can kind of see what we're doing. And then the next line will officially save it as a variable. So we have that. I did not catch this until later on, so I didn't go back and change it in the original model. But take a look right over here for the state of Massachusetts. Okay, apparently on September 2nd, they noted negative 7,757 cases. That's obviously backtracked from previous days, and so they're backfilling on this today right over here. That's not really a valid value. And so it was throwing some of the results off earlier. There may have been more values like this. I didn't go ahead and double check. I just pulled in the stuff. The only reason I noticed this is because the error value here was negative. When we looked at the actual error totals, the values were invalid, so we saw this right over here. So my guess is if we were to remove this value from the original data set, the error metrics for the original forecast probably would have been a little bit better. But in any event, so what we're going to do here is we're just going to take, right, where this value is equal to negative 7,757. And we're just going to go ahead and then make it the value, average value of Massachusetts itself. Okay, so these things right over here, all right, we're just going to take the average value of that. So now if we take a look, just to kind of confirm what we just did, this big ugly number right over here, which is going to throw things off, Okay, it just got set to 326 and some change right over here. All right, to make it a bit more appropriate. Okay. The same thing, what we're doing over here, right? We are calculating the absolute error for every single line inside the data set. So if we do this, okay, we have the prediction, we have the true value, we have the prediction, and then we have the absolute error. Okay, and so what we're doing over here, we want to get this for the entire data set. So if we were to aggregate this value over here for the entire whole, for each state entirely, okay, so this, right, is the sum of all the error for each of the individual states. And then the idea that all we're doing is we're just dividing this by the total number of cases. All right, and so here, right, we have the mean average percent error on a state-by-state basis. Some of these numbers look pretty gruesome. The only thing we want to be cognizant of, excuse me, is just that some of these things had almost no values to begin with, okay, which is a common issue. So some of these individual states right over here, they may have had 10 or 15 cases, and then our top-down projections kind of boiled down to maybe like 100 or 200 different cases. So their fraction of the total is actually minuscule, which just means the error is very easy to be unreasonably large. Okay, so you'll notice here, for the states with more cases like Florida or Georgia, if you go over to California as well, you'd see it. Okay, we're actually kind of getting close to the results of the top level model, but for some of these smaller ones right over here, they're horrendous simply because there just weren't very many cases to begin with. So the idea then, if we're going to take the mean average percent error for all of our individual units, we want to go ahead and take the weighted average just to account for how many cases there were for each one of these individual states. Okay, so what we're going to do here, this line right over here, which is basically the mean average error for each of the individual states, we're going to save it as a variable. And we're going to do that right over here. Okay, and then what we're going to do then, okay, is we're going to take the state totals, and then we're going to get the percentage of total cases for every single state. Okay, so what this tells us, right, is within our validation set, about 9% of all the cases belong to California, so on and so forth. And so we're going to take this, and then we're going to merge it with state errors to get sort of the weighted average percent error for all of our 50 units. All right, so if you do this, right, so within our validation set, what percent of total cases existed for each of the individual states? Again, I'm just going to save this as a variable right over here. All right, and then the idea then is we're going to take the average, the weighted average, and then multiply that by the errors. Okay, so this is the weighted metric term for each of the individual states. And then what we're going to do then is go ahead and then just add this up, which gives us a score of about 0.4. Okay, and that was actually the end of the lesson 2 weeks ago. And so we're going to go through different versions of this to make sure it sticks in our head a little bit more. All right, but let's see how we're doing. Questions? There's a lot of steps in between, right? There's a lot of grouping and merging and things like that to kind of go up to the top level and down to the bottom levels and things like that, and to make sure you can perform operations on the validation and the predictions and things like that. But it's actually why it's a fairly advanced topic that maybe not a lot of people have a lot of experience with, because you kind of are in the wilderness a little bit. But that was kind of our first rendition of kind of working through the problem, kind of the step by steps. And also what's probably important too is that just the mechanics of it are fairly complicated. And then also what's fairly common with the top-down forecast, the top-level forecast was actually more accurate than for the individual components. So you could say we did a better job of predicting COVID cases at the national level than we did predicting the proportions for each of the individual states. Okay, because if our predicted proportions were about as accurate as our predicted forecast, the mean average percent error for the individual states would be about the same as the top total, but we could see that was not the case. Okay, so what we're going to do now is we're going to try different versions of getting percentages for each of the individual states, and then go through the processing steps that we just did previously. And then we're going to do that 2 different times. So we're going to look at the moving averages for different states over the last 14 days. And we're also going to take an historical average. But before we do that, let's just see how we're doing. If some of the steps are a little bit confusing, I would say the idea is that's what we're going to practice for the next hour to hour and a half. All right. But before I do that, questions from you all. Okay. So we okay?
Yeah, I'm good for now.
Good for now. All right. All right. Okay, good for now. Thank you, Shella. All right. So the idea is, right, so we had a national forecast with a mean average percent error of about 0.2. And then we had a weighted average percent error for the individual states of about 0.4. So our proportional forecasts were twice as bad as the national forecast. So what we're going to do now is go through this step. Okay. And then see if we can go ahead and then improve upon that. All right. So what we're going to do next. All right. You can do this in the same notebook if you want, or maybe start a new one. We're going to go ahead and test out historical proportions and then rolling 2-week proportions to see if we can go ahead and improve on this number right over here. Okay. So what we're going to do here as a group exercise is take a look at the historical proportions. All right. So what we're going to do here, right? I actually don't think we need this one. Okay, let's go back to DF train. Okay. This is the average proportional amounts of each of the individual states in our training data. So what this means, we look at DF train head. All right, so these are the daily proportional values for each of the individual states. Okay, so if we take the average value for each of the states in the training set, we get this right over here. Okay, so this is basically the historical proportion for each of the individual states on the data we're actually going to train our model on. Okay, so that's what we have right over here. Okay, so let's save this as a variable. So next cell right over here, we're just taking this and then saving it. Okay, and so now what we're going to do, we're going to do something a little fancy. All right, you can take a data frame and turn it into a dictionary, which is what this line does. Notice here there's a key called Y. Okay, and then, right, we have AK right over here like this, Alaska, so these historical values. So the idea then, if we just grab the Y key, we will have this dictionary right over here. And so these are the historical values. And so what we can do is we can actually take this and turn it into a data frame. Like this. All right. So remember before we had the data frame called estimated ratios, and it was the predicted proportion for every single one of the individual states. So here all we did is we just recreated this, except this time notice here the value for each one of the individual states is just the historical average for that particular state from our training set. Okay, so basically what we're going to do is we're going to try and take our top level forecast and project it onto this thing. All right. So let's save this as a variable. All right, so the basic idea, this is where I'm going to turn it over to you. All right. So the idea is estimated ratios, the original data set. Right, these were the forecasted proportions that we had day by day for each of the individual states. Okay, we're going to try a different set of proportions. Right, and this time all we're just doing is we're just using the historical average for every single day. And so the idea is, if you remember, we have these predicted values right over here, right? So essentially the challenge that we have, right, we're going to kind of do a replay of the previous steps that we had. Okay, and so what we're going to do then, right, is for each of these corresponding dates right over here, all right, we're going to go ahead and then we're going to project the predicted value onto them and then calculate the mean average percent error, the weighted mean average percent error for the state. So we're going to see if we can do a little bit of a dress rehearsal. Okay. Of essentially the last section of class from 2 weeks ago. Okay, so the idea is when you're done, and you can just kind of see about sort of, recreating some of the steps that we did previously. Okay, we want to see if we can go ahead and take from our predictions and our ratios and get to this number right over here using the historical values. Okay, is everyone okay with what it is we're going to be trying to do? Okay, it is fine to go back and just do some copying and pasting and kind of keep track of the different values, things like that. Also, I didn't really have time to turn this into a proper lab, so we can just kind of stay inside this notebook right over here. All right, but the basic idea then right? We have our ratios here with the historical averages. We have our predicted values, right, for the very, very top level forecast right over here. And so can we take these two things right over here and eventually work backwards to get the equivalence of this number right over here, okay? So there are a few steps in between. Just to kind of give you a little bit of a few hints, some of the variables that we have stored so far, you can actually reuse them if you would like. Okay, so for example here, if we scroll through, so this thing called state vowels, all right, you would need to use this again, right? These are the state totals day by day. So if you wanted to, you could go ahead and then re-merge back into this if you wanted to. Okay, and of course you have the answer key right over here like this. All right, so feel free to go ahead and then take a crack at it. Any questions about anything? Nope. Okay. All right. So let's go ahead. Let's take about 20 minutes. Okay. All right. So I'll go ahead and go off camera. And again, there is a the answer key is essentially right there. Although actually, I think I did make one mistake here. I don't think I should have gone through this particular step right over here. So this one, you could probably just omit this. All right, if you wanted to. but then everything else should go ahead and then carry over pretty well. So give it a shot and then see how it works for you all. And then we'll reconvene here around 2 o'clock. Okay?
Sounds good.
Beautiful, everyone. Talk soon. Welcome back here. Let's just walk through that example, okay, step by step, and just make sure we're clear with what's going on. And then probably as a carryover, there will be a second thing we can work through, and that can be a little bit of a homework, okay? And then we can just kind of post solutions in the Slack channel and then go from there. All right, so everyone, let's go ahead. So the idea was, right, just to go ahead and recap, we built a forecast for our proportions and then, basically projected our top level predictions onto those and then calculated the weighted MAPE for each of our individual states. And then the basic idea is the top level forecast had an MAPE of about 0.2. The state level forecast had an MAPE of about 0.4. Meaning our COVID predictions were more accurate than our state level proportion predictions. And so what we did now, right, is just kind of compare something that's actually a lot more simple, because instead of fitting a time series model to forecast the predicted proportions day by day, we just took the historical averages. All right, so to walk through things step by step. All right, let's go ahead and do this. I am probably not showing my screen, am I? I don't think I am.
No.
No, all right. All right, so sharing now. All right, can everyone see? Probably in a second here, hold on. Okay.
Yeah.
Okay, all right, beautiful. All right, so just to recap, okay. Where we started off with, let me see if I can find my place inside the notebook here. I think I need to go down, 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 down. Okay, all right. So the idea is trying, right, some different strategies for the ratios of the individual components to kind of narrow the gap between top level and bottom level accuracy. Okay, so basic idea. All right, so basically what we started off with, right, this thing called estimated ratios 2. And then here, right, the values are not dynamic. Okay, these are just the historical proportions for each of the individual states within the training set. That is basically it. Okay. All right, and then we still have these top level forecasts right over here, right? So we have the date right over here, y hat, and so this is kind of what we're going after, right? So taking these values for 28 or 27 or 24,000 and then projecting them onto the individual states to get their values. All right, so with that being said, let's go ahead, right? So the first step, which can be a little tricky, all right, is taking each of these individual values right over here for the top prediction and then projecting them onto each of the individual states right over here. All right, so let's go ahead and do that first. All right, so right, there are lots of tricky things with indices and groupings and things like that to actually kind of get things at different levels. So let's do this. So estimated ratios 2, merge. Okay, and then we will merge it with these two things right over here. We'll keep the index. By the way, depending on how you have some of these things set up, some of the individual steps might be a little bit different. But the idea is over here on the left-hand side in my notebook, right, we have the index. So we'll do this. So before I'll commit to it, let's do this. All right, and then, yeah, all right, so we have the date right over here, and then we have the actual predicted value right over here like this. Okay, so it looks good. All right, so I think we all got to this step, right? So just taking the ratios with the date and then with the final predicted value right over here. Okay, now the idea then, right? So we have EST underscore ratios 2. And so essentially what we want to do all right, so good question here. So why do I get, so big thing here is when you get the underscore X and the underscore Y, it means you're merging two data frames that have the same column labels. And so the one on the X will be X and the one on the Y will be Y. So just as basically what that probably means, Edwin, is you probably ran the merge command twice. That's what my guess is, okay? Because the idea is here, notice here, right, I have ds and y hat right over here. Okay, if I were to merge this a second time, okay, so I do this, right? And then we'll say on ds like this. Now the idea is est underscore ratios 2 already has a y hat column in it right over here. And so what we're merging it into also has a y hat column, okay? So the idea is, since we're merging on ds, this label right over here would stay the same. But now when we're done, there's going to be two y hat columns, this one right over here and this one on this side. And so now if you merge it like this, you'll have y hat x and y hat y like that. So probably what happened, Edwin, is you just literally, if you run a merge command twice, a lot of times you'll start multiplying these different columns right over here like that. And that's probably what happened. Okay. Yeah. All right. So usually if I were to do something like that, I mean, I think this underscore x underscore y, it gets a bit messy after a while, right? So you could just drop is equal to 1, and then you could rename. You wouldn't have to do this, but if it's just easier to keep track of things. If you were to tack this on to the same message, it would be a little cleaner over here like that. Okay. Okay, all right. So we have a slightly updated version of this. Okay, and then big thing, right? So essentially what we want to do is for every single row in our data set, take this value and then multiply it by our proportions right over here like this. There's not a really clean way to do this. So basically what we did is, so any number of things you could do here. So we could do something like this. So estimated ratios, columns. We could go all the way to the last two, right? So that would grab everything but the last two. We could turn this into a list. Okay, right? So we'd have state calls right over here. All right. And so same thing. All right. And so now, right, this thing prids df, right, are just our actual ratios right over here like this. All right. And so now the idea then the row is going to be equal to itself multiplied by the y hat column and estimated ratios to at the same index position. Does everyone get that? So for each one of these rows, right, go into this one, find the y hat column at the same index position, and take that value and then multiply it across all of these. All right, so if we do this, we get something that is not quite right. That's the reason why we actually had the last line, because row isn't actually attached to anything. So a few different ways we could do this, but all right, so what we could do here, this actually might be a little bit easier. Is just set it equal to this. Yeah, and then we got this right over here. All right, so what we could do then, all right, now I'm running into the same issues here. Okay, 1 second. All right, big issue here. All right, so prids df. Notice over here, the index 6, 7, 8, 9, things along these lines. Okay, so what we're going to do here, this is maybe one of the hard parts about these sorts of things, is we'll reset the index. It'll just take this value back down to 0, because what it's doing, okay, it doesn't exist because there are not 200 rows inside the data set. What it's doing is it's looking at this value right over here, because that's the index value. But the issue here, though, is that it is starting at 6 versus 0. So if we reset the index, it'll get back to 0 right over here. And then we will drop this column because we don't really need it. Okay, so that's what we're going to do here. 1 second. All right, so resetting the index right on our predictions, and then going through every single one, and then just setting the value right over here to whatever it is, this particular row multiplied by the y hat value at the corresponding row right over here. Let's run this. Key error 0. All right, let me take a look here. Row, key error 0. Let me take a look. Sorry, everyone. Okay, so it's the same thing. All right. Do you see what I'm doing here with resetting the index? Just to make sure the index positions match, and we're using iLoc, and there are no error messages.
Yeah, that makes sense.
Okay, all right. That's this. All we're doing is just making sure the indices match one another, so they both start at 0. So that way, when we say, you know, grab iLoc y hat at this one, and then iLoc for the other one, they're referring to the same thing, and it just matches the number of rows inside the data set. So we're just making sure the indices match. And then this error message, if you get the index position out of bounds error, that's usually basically what that means is when you're using iLoc right over here, there's no actual index position this big. Like, you don't have 250 rows inside the data set. So you get this thing right over here like that. And that's what the error message is. All right. So yeah, it's just going from one data frame to the other can be a little bit cumbersome, as we saw. All right, so we'll do this, reset the index, and then drop it. Okay, and then now, okay, all right, that was what we wanted, right? Okay, so we just went ahead and go through it. And so the big thing, right? So now our predictions df. Okay, right. The start of the time series doesn't make a lot of sense, but the tail, right? The value should be a bit more normalized. Okay, and so these are really, really, really big numbers. All right, let me take a look. I think I ran through this a bit too many times. Let me try this. I think this is probably a few multiplications on top of each other because this is a pretty big number. So probably not the number of COVID cases. If this is the number of COVID cases, I think we'd all be dead in probably about 3 weeks. A really, really large number. All right. So let me just kind of go ahead and just resort some things here. True. Okay. So we have this. Right. And again, we're just resetting all the indexes back to 0. So that way we can just loop through them and make sure the two of them are the same. Let me just check to make sure. These numbers right now are copacetic. Okay, that looks good, right? Like those are just kind of some boring stable predictions, ratios. Okay, we have 0 to 4 like that. Okay, and estimated ratios. I think what happened is, I ran this cell a few times, and so we were getting 2,000, multiplied by 2,000 multiplied by 2,000, and now we got this big numbers. I'm guessing that's okay. All right, yeah, we look good. All right, so let's run through this. Okay, all right. So those are nice, normal-looking predicted values, right? So California, 2,000 or 3,000 values, whatever there. Okay, and so same thing. Let's do this. Remember, PRIDS DS has the same number of rows as estimated ratios. So we're just saying take the date column over here, and then we're just going to ape it over here. All right, so let's do this. Okay. All right. So that was kind of one of the first steps, right? So the tail looks better, right? Some of the beginning values look a little nonsensical. Okay. So here, right, we have every single state, their predicted value, which is pretty much just taken, right, by the proportional value of each of these by the prediction at the top of the data set. And then we have DS right over here, okay? Now, just to make sure, now the idea here, so these are actual predictions right over here, okay? But the idea then, what we need to do, okay, we actually need to be able to map this data frame right over here to this one right over here, okay? Is everyone with me there? Because this is the one that actually has this, day by day, each state, and then how many values there actually were. Okay, so we have something similar here. We have our predicted values for each of the states, but we need to go ahead and then sort of reconcile it with this one right over here for our calculations. All right.
What is the value column in the state vals table that you just showed?
This one right over here, that was from the previous round, Shella. Remember we walked through like the first one with using the predicted ratios from the profit itself.
Right. Okay, that makes sense.
Yeah. So just because, we're just reusing this because it still has these things right over here, but this is just from the last round of calculations.
Okay.
Yeah. So the idea is we are actually just going to recalculate these two right over here, but for this instead. Okay, and then the only idea here is this already has our grouped values for all the individual states, so we're just reusing it again. But we don't need these things anymore.
Cool.
Okay. Alrighty, so what we can do here, right, we just need to create these one more time. So what we'll do here, we'll just drop these over here because we don't need them. Okay, so we'll do that. All right, and so state vals is over here like this. Okay, right, so now the step, right, is taking this and then matching it with this one right over here. And just so you know, this is why we actually added the date column. Okay, so that way we can map the date with this one the date over here like this. Okay, but also the issue we have though, right, is this data set is organized horizontally. This data set is organized vertically. Okay, so the idea then is we actually need to go ahead and create a column, right, for each of the individual states versus having every single state be its own individual column like this. Okay, so we need to compress this. All right, and so that's what melt does. All right, so we do this. ID vars basically says just keep this one as sort of the underlying index to map everything else by. So if we do this, now our data set is shrunk. And then also really importantly, we should be able to say, right, so we have a state and a date here, and then a state and a date here. And then we can easily compare, right, this value with this value to go ahead and calculate our error. So that's the basic idea. All right, so we'll save this. All right, and I actually remember Ricardo, right, during Unit 2 when you took the class, you discovered this method and were quite fond of it. And it's pretty powerful, right, because it allows you to sort of reshape data frames on the fly. All right, so now we do this, prids df. Okay, these are our predicted values, every single state, every single day. And then we have state values. And so this is basically the answers in our validation set. Like this is the actually observed total for every single state, every single day. So what we're going to do, right, is just merge. Okay, and then all we have to do here, we're going to merge on the state and the day. Okay, so therefore we'll be able to map, right, this particular state on this particular day with this corresponding values over here. And so if we do this, I think it's called variable on the left-hand side. Okay, so left on. Okay, all right, and so now we're back to this. Is everyone with me so far? All right,
Yep.
basically, right, just allows us now, we actually have every single state, every single day. We have the observed value, and then we actually have the predicted value, so therefore we can go ahead and do our error calculations. So let's save this. All right, and so now we can figure out basically our final results. All right, the same thing, what we're going to do, so mean average percent error, so basically means the total amount of error that you have, what percent of the total is it? So first thing we'll do here, okay, so this is just the error column, and then we'll take the absolute value of it, right? So mean absolute percent error. Okay, so now once we're done with this, we'll take a look at it. Okay, right, so the answer, our guess, and then how much we were off by. Okay, right over here like this. Okay, so now the idea is what we're going to do is take the weighted value of this. So if you take a look over here, if we group by the state, okay, this is the total number of COVID cases state by state in our validation set. If we do by the absolute error right over here, Okay, this is the total amount of error, right, for the data set. So the idea then, so just what we'll do, just divide one by the other, and then Shella, to your question, right? So the division we're doing by is literally with these values right over here. So each one of these is a series with the state values for the index and the corresponding number right over here. So that's what's being divided. Okay, so we do this, and so for each of our individual states, okay, this is the total amount of error that we had by the total number of cases. So we'll call this one, right, MAPE, like this, on a state-by-state level. All right, how are we doing so far, everyone?
Good.
Good, good, good. Okay. Now, the only thing we want to adjust here for, right, is states have very, very different levels of total numbers of COVID cases. And so it will often be the case we might radically overestimate. So if we have something, if a state has 10 or 50 cases per day, and we predict 100, our error rate will be off by 100%. And so this number will look really, really, really large, but it's not really weighted for how frequently cases occur. So the idea then, right, we have this thing right over here for each of the individual states, but we just want to go ahead and then weight it by how much of the total cases each state represents. So what we're going to do here, okay, so total number of cases in our validation set for each of these ones. All right, and then what we can do here, actually, if we want to, we could just do this, right? Sum the sums. Okay, and so that would be the total number of cases total throughout the entire period. Okay, I did it a different way in the solutions manual, but it would come out to be the same. Okay, so the idea here, if we do this, okay, for each individual states, this is the portion of total cases that they represented. Okay, so we could do this. If you want to do a quick check, we can make sure this just adds up to 1. Okay, and it does, so it's a true percentage. So now the idea then, our MAPE, right, this is our average percent error for each of the individual states. But the idea is we can see here, right, it's more accurate for Florida because Florida has bigger numbers, whereas some of these smaller states, like Massachusetts, is probably a little bit off, simply due to some faulty numbers. But the idea then, if we do this, multiply by the state portions, okay, we should get numbers that look a bit like this. Okay, so now the idea then, what we ought to be able to do is sum this up, and that'll give us the weighted average throughout our entire data set. Okay, and so we get this right over here, 0.57. Which means using historical averages does not actually improve things compared to just predicting the proportions with profit itself. All right. Let's see, could we follow along? Or questions or steps that were maybe not particularly clear? Okay, Edwin is good. Okay, all right. So what we're going to do here, we're out of time for today, but as a homework assignment, as a way to follow up for this, we can try one more option, okay? All right, so the idea is historical averages ended up being kind of dumb, which sort of makes sense because the proportions of different states has actually varied quite a bit throughout time. In fact, if you actually look at what we have here, so if we look at this, you'll notice here where it actually gets consistently really bad is with states who had bad cases of COVID early on and then are not so bad now. So New York would be an example, right? So if you multiply this by 100, that's a really bad number, right? Because now New York's portions of the total are quite small, but historically it's been very, very high, right? So same thing here. We see it here with Massachusetts. Also, if you remember, Washington was the first state to get COVID. So at the beginning of the time series, they consistently had 100% of the values, things like that. All right. So in any event, this is just a bit too crude for its own good. All right. In my opinion, the predicted values from profit also may be left a little bit to be desired, right? Our MAPE for the individual states was twice as bad as sort of the top level model. So what we'll do here, if you want to continue with this until our next meeting, we'll actually try something intermediate. Do we remember from DAT when we discussed moving averages or rolling, the rolling method? Okay, so we'll go ahead and then see. All right, I appreciate the honesty, Shella. So that's great. All right, let's take a quick look here. All right. Let's try one more way. We're not going to finish this today, but we can work on it later on. Okay, the idea here, if we take a look at our original, so I've lost track of some of these variables, all right? So, okay, all right, it's easy to do. All right, so we look over here at DF train. All right, so the idea here, we have this value y, right? Things like that, or whatever, the country total, all that kind of stuff. Okay, so the idea then, let's suppose we grab y right over here, and we say rolling, make it 3, and take the average. Okay. Let's take a look. So you see this value right over here. Okay, 1.465840 e to the negative second, like that. Basically what that means, if you take the first 3 values of y, you take its average, you get this number right over here. Okay, now if you look at the second value right over here, right, so basically if you move everything up 1, okay, you will see, excuse me, I got ahead of myself. It is 1 through 4 like this. Okay, this number right over here is this number right over here. And then if you go 2 through 5, right, this number right over here is this one right over here like this. If we take a look, all right, so basically it's like a sliding window, okay, is what it is. And so in this case, if we take the 3-day rolling average, it'll always look at windows of the previous 3 values and take their average value and then move the window up 1 and then so on and so forth. So if we were to go ahead and take the average value of the numbers 3 through 6, right, we can see this number is that one right over there. Okay, and so in this case, this would be a 3-day moving average, but you can do 10 days or 14 days. And the basic idea is it kind of gives you a sort of a feel for how a certain value is moving over time, but you're not overreacting towards any one particular event. And so therefore, it kind of gives you a smoothed out value, sort of feel for how a value is moving over time. Okay, so Shella, it seems like you're good. Edwin and Ricardo, does that ring a bell? Actually, Ricardo, I remember from your exit ticket, you actually liked the moving statistics when we discussed them. Both of you, this would have been covered around class 8 or class 9, so towards the end of unit 2. All right, yeah, so the whole idea behind moving averages is it allows you to capture dynamics and how a value changes over time. And so it both allows you to kind of take something that's smoothed over so it doesn't jump around too much, but at the same time captures like some sort of feeling of momentum or trend within a particular value. Okay, so the idea here is where we'll kind of follow up this particular discussion is we started with the predicted value of the proportions. We also looked at the historical averages. The historical averages did better. I'm sorry, no, the predicted values did better. They're a bit more dynamic. Something that might be a little bit in between would be to look at the moving average of proportions for each of the 50 states at the end of our validation set. Okay, so let's take a look. So what we're going to do now, we're going to do some fancy indexing here, okay, to get these things to work. Okay, so we take a look over here, DF train. Okay, so the idea is for each of our 50 states, all right, we want to calculate the 14-day moving average and then take the value of the 14-day moving average at the beginning of the validation data. Okay, so sort of like the last recorded value of the 14-day moving average for proportions for each of the 50 states. Okay, so kind of wherever that value was when the validation data began, that's what we want to go ahead and use for our proportions. Okay, so everyone ready? This is, again, it's fancy indexing. We did cover it in class, but maybe not exhaustively, so this might be a little bit of a refresher. All right, so what we're going to do, let's take DF train. All right. Now, Shella, we're going to do some things that were covered in your class, but weren't explicitly covered in Ricardo and Edwin's class. Let's take a look. So DF train. All right. So class 8 in Shella, we talked about the multi-level index, and we actually used moving rolling statistics inside the lab. It rings a bell. Let's go ahead and take a look. So let's do this. All right, and let's do one more thing here. Let's sort index. Okay, let's make sure we're here. I can check here, make sure we have the same thing. If you're still following along.
Yep.
Okay. All right. So right here we're looking at panel data, right? So we have individual panels for the states and then the dates moving in descending order. All right, let's do this. So DF train rolling. All right, so what we're going to do now, the idea then, so what we want to do, we want to calculate the moving average for each of the 50 states, all right? And so this is why we have the multi-level index. All right, let's see. This was not explicitly covered in Ricardo and Edwin's class, but Shella, let's see if you remember this. So this is level 0. Right over here, right? So level 0, level 1. So we're saying at the state level inside the index. Let's grab the Y column. Let's calculate. Let's take 14 days. So basically the 14 here says, go back 14 dates and take the average. Okay, and so what this is going to do, okay, is, right, the first 14 values for each one of these states are going to be not there because there wasn't 14 values to go and go by. But here what we have now is this is the 14-day moving average calculated, right, for each one of the states. And then also what we want to do is we want to take the last recorded value of the moving average for the 50 states in our training set. So what we're going to do here, last, like this, and we're going to get an error message, and I'm going to wave the white flag a little bit and go back down into here. Okay. Sorry, that was it. So what we're going to do over here, I think I lost track of where I was in the notebook. Okay, here we go. All right. Let's try this one. I think this might be a data frame method, so let's try this. Add the double brackets. Let's try this. There's something that I'm missing here. You know what? Hold on. Let's just do this. 1 second. Okay. Hopefully I'm not meandering too here. Let's just save this. Okay, so we have 14-day moving averages for each of the individual states. And there is one step here that I'm missing. I'm just going to kind of take a sneak over here. Ah, okay. Got it. Got it. All right. Sorry, one more step that we have to take. All right, so let's do this. We have to do it in multiple steps. All right, so 14-day moving averages for each of the 50 states right over here. And then we're going to group this one more time. And take the last value, and then here we go like that. Okay, and so that'll give us the 14-day moving average at the very, very end of our time series for each of the individual states. Okay, so let's do this. Okay, make it a proper data frame. And so the idea is, right, this is a different set of ratios to use. So we've tried the more dynamic one with the forecasted values. We've tried the simple one using the historical averages. And so in this case, what we're doing is for each of the 50 states, the 14-day moving average of their proportion of the total is listed right over here like that. We can save this as moving average ratios. All right, and again, what we would do here, are we still around, everyone? Have I lost? Sometimes I feel like towards the end of the class, things get mushy. I tend to actually am not quite as sharp, and I'm not quite sure how attentive everyone else is. A few more minutes. Okay, all right, so Shella is still good. Edwin, Ricardo? Okay, all right, let's do one last step, all right? So if we were to look at the 14-day moving average of proportions for each of the individual states at the very end of our training set, this is what these values would be. So same thing, let's go ahead. Let's turn this into a dictionary. Let's grab the Y key. Okay. And then let's turn this into a data frame. Index. And I forget what the date index is, what variable we have it referred to as. If anybody has it, let me know. But actually, I think we can probably use any one of these. So let's just try this. Yes, right over here. Okay, yeah, that should work. Let me just make sure. I forget what value I used here in the very beginning. You could probably use any number of ones. But just to be consistent here, let's take a quick look. Okay, yeah, here we go. Estimated ratio. This is the good one. Yeah, this is the right one right over here. Okay. All right, so now the idea then, if we were inclined, and it's up to you if you want to do this. All right. I lost track of where I was inside the notebook. Okay, yeah. All right, but this right then is the ratios for each of the individual states. But the idea is these ratios might be a bit more informed than just taking simple historical moving averages. And then the idea then, right, if we wanted to compare, we could go through the same steps again. There are any number of things you could try in addition to this, but that would probably be a good way to conclude kind of how you might take sort of top level forecasts and then project them downwards. Okay, and this would be something in between using the forecasted proportions and then the simple averages. All right, and that's where we will leave off with today's class. Questions? Of course. Sure. It'll be in the Slack channel afterwards, but basic idea is it just this last line right over here?
This is a small question, but when you, for cell 520, is it necessary to do the group by again? Because I noticed that added like another second level of like the same state.
Yeah, no, actually, I'm pretty sure you do, simply because you can't tack on last. If you could just do something, Shella, like this, like that right over here, then it wouldn't be necessary. But in this case, it doesn't actually allow you to do that. So you have to regroup it one more time.
Oh, not like concerning 524, but just for 520, like if you were to
Right.
show DF train rolling,
Yeah.
I remember it had like two state level.
No, if you no, the idea is we're grouping the grouping.
Oh,
So simply the idea is so that way we can actually get the last value of the averages.
got it.
So it actually, no, in this case, it's not superfluous.
Okay.
You just have to, you have to group the group values. So the idea then, multi-level index right over here, Shella.
Mm-hmm.
Okay. And then actually, let me take a look here. You might not have to do it. Hold on. You might. Let's just try. All right. So we group by state. Y. Okay. Get the 14-day moving average for each one. Okay, which looks good. All right. Now the idea then is we want to get the last value from each one of these individual panels. And I'm pretty sure. Yeah, I'm pretty sure you have to, Shella. Like, I don't think there's any way you could just, from this statement right over here, let me try again. All right, so let's save this. So now the idea then, if we could just do this right over here, Shella, it wouldn't be necessary. Okay, but we can't. And then let me check to see if there's one other thing we can do. All right, and so, all right, offset. Let me just try one more thing here, Shella, okay?
Okay.
I think the reason why I did it a second time is just so we could get this right over here and then. Yeah, I think we would have to, because simply the idea here, it's a complicated index, but just the idea then is if you just grab y right over here, it's not actually associating the value with these date time indices, and so therefore it doesn't really know where to go. And so, yeah, it's a little bit excessive, but I am pretty sure, because if you just do this, y last, right? There's nothing about the offset, and then offset is equal to 0. Okay, it doesn't work because it's not really seeing the date time index. But then like this, that actually does work. So
Okay.
I think that, yeah, that's actually, it's necessary, Shella.
Okay.
Yeah. Okay, simply because just to make sure this method right over here gets tethered to the date time index. And then the idea is, in order to get the moving average for each of the 50 states, we have to use this one right over here. And then we have to group it again to get the last one of those each values. And then we do this right over here. And then that's pretty much September 1st. That was the 14-day moving average for each of the proportions for all 50 states. Anything else? Okay, so Edwin, you saw it. All right, everyone. So let's wrap it up here. And again, I will post the next date here for this meeting. It's probably either going to be 2 Saturdays from now or on the preceding Thursday. It just depends on my schedule a little bit, but I will let you all know, okay? And
Okay.
then probably what we're going to do here is we're going to do bottom-up forecasts next time to see if we can improve our results. And then probably after that, we might have more of a longer form lab with a new data set, where we might have something where maybe there's some sort of inventory of different stores and products and creating some sort of hierarchical forecast for individual stores or regions or things along those lines. And then after that, we'll probably do the Bayesian deep dive in terms of how profit is fit. So all in good time, right, everyone? So hopefully hope to see you all again soon. Thank you for coming, everyone. I appreciate it. Okay. Thank you.